Hey guys, welcome to the last lecture day, and this time I will be going over functions and basic PowerShell commands. And before we dive into today's material, let's go ahead and answer some quick questions on what we've covered already. So real quick, just go ahead and pause the video and try to answer these questions on your own, and then I will go over them. Alright, so the first one, what are the 5 different loops I went over? So that's going to be the while loop, the for loop, do while, do until, and then the for each loop. Alright, and then number 2, what flow control will test multiple conditions only one time? So again, there we've got multiple conditions and then one time, so it's going to be a switch statement. Number 3, what flow control will test one condition only one time? That is going to be the if or an if-else statement. And then number 4, what flow control can test one condition multiple times? So this again, it can be any type of loop. Number 5, what is one way that a loop will create an infinite loop? So the easiest way for this would be if the variable in the conditional statement isn't modified, which would result in an infinite loop. And we've got number 6, if both statements are true in an XOR, what will be the output? So XOR is one or the other, so it would be false. And then number 7, we have why do I not need to check the second statement in an OR if the first one is true? So this is because only one or the other needs to be true. So if the first one is true, the second one could still be false and it will still result in true. And then number 8, why do I not need to check the second statement in an AND if the first one is false? So it's kind of the opposite of the OR here. So we've got, so AND needs to be, both of the sides need to be true. So if the first one is false, it doesn't matter if the second one is true or false because it's still going to result in false either way. And then number 9, what are the 3 parts included in the for loop? So in the parentheses there, it's going to be, the first part is the variable initialization, and the second part will be the conditional statement, and then the third and last part will be the variable modification. And then we have number 10, what loop will always run the block of code at least one time? So I'll accept either do while or do until for this one. All right, so now I can go ahead and dive right into what we'll be covering today, which is functions. So we'll go over a bit of an overview of functions, why we use functions. We'll go over some built-in functions, creating user functions, how to call a function, passing and receiving function parameters, and then returning a value from a function, and then the scope of functions and what exactly that is, and then as well as go over some exercises. So you may be wondering, why even have a function and what exactly is a function? Really, a function is just a grouping of code and will have an optional input and output. So again, it's just really a grouping of code. That's what a function is. So a reason for this is if we want a part of code to do something without having to retype it over and over again. So we can have a function set to do something and can use it more than once, but only have to create it once. So for example, we could have a function set to find the perimeter of a circle if you're given the radius. So if we are given the radius of a circle, then it would run that function to find the parameter of that circle for us just by calling that function. And another thing with functions is that if you make a mistake in a function, you'd only have to go back and correct that mistake once by going to that function, fixing just that one part, versus if you were to copy and paste the code 10 different times, you would then have to go and find all 10 of those times you pasted it and fix it 10 times. Versus again, a function, you just have to correct that one spot in that function. Another thing is usually whenever you see functions in programming, you'll often see a main function that calls other smaller functions. So just something to note there. All right, so PowerShell already has a bunch of built-in functions. It has thousands of built-in functions, and we've already used a few of these, such as get variable, get random, and get date. So here's an exercise for you guys. I want you to go and open up PowerShell and type get variable or get random, and then hit enter. And then tell me what would be the expected output, and then try some different attributes with it. All right, so user-defined functions are functions that a user can make that PowerShell doesn't already have. So if you want to create a function to do something in PowerShell, it doesn't already exist in PowerShell, then you can go and write your own and then utilize it. So when you create a user-defined function, you will need to both declare or create the function and then later on call the function to make it run. So an important note here is that you only need to declare a function one time, but you can call a function as many times as you want to use it. All right, so here's an example of declaring or creating your own function. So we've got 4 different components here of this. We have the function keyword, the custom name, start and end curly brackets, and then the code statement. So first let's go over the function keyword. So we start off a function by putting function first and then naming our function whatever we want. So here in our example we have write seconds per day. That is our custom name, write secs per day. And then we have our open curly bracket and close curly bracket. That's the start and end there. And then we have our code statements. So we have hours, the variable hours equals 24. So we're setting 24 to be hours. And then we have minutes set equal to the hours. So 24 times 60. And then we have seconds is being set equal to minutes times 60. And then here we're just returning seconds. And then at the bottom here, we are calling this function. So we're writing seconds per day. So whenever I put this here, just writing out the name of the function, it is going to call this function and run this, and so it would return however many seconds are in a day. All right, so now I'm in ISE, and I'm going to go ahead and show you guys the exercise that was at the bottom of the last slide, which is to write a function that prints your name. So I'm going to go and put CLS at the top here, make my comment block. Okay, so that's going to go and tell us what this program is going to do. And then so now we're going to go and create our function. So function, and then we're going to name it. So let's do print name. And then we're going to open our brackets, close them there. And so here's what we would do. We would put, so we're going to go and ask the user for their name. So name equals read host. Please enter your name. And then we will go ahead and output write name. Right, so at the top here, I'm going to go and run this script. I'm going to go and call the function by typing print name. So please enter your name, Chris. And there we go, it prints out my name. All right, so now I'll be covering parameters. So parameters are just variables that you can pass into other functions. So normally, if you create a variable in a function, it will not be able to be used outside of that function. However, if you pass that variable as a parameter, then you can use it outside of that function and perhaps into another one. So when the function is being called, parameters are space separated after the function name. There are no parentheses and no commas. As you can see the example here, we're passing 5 into the function here as a parameter. So as you can see here, there's no parentheses, no commas. We are just putting 5. And for an exercise now, I want you guys to try to go ahead and write a function that divides a number by 2. All right, so I'll go ahead and show you guys the example of the function to divide a number by 2. So at the top here, obviously you're going to put CLS, and we're going to go ahead and create our function. So we're going to name this function divide by 2. And in here we will put our variable number and then divide by 2. And down here we'll go ahead and call the function divide by 2 and pass the parameter number. So here we'll go and ask the user for the number. Number equals read host. Please enter a number. And since we're running a number here, I'm going to put integer before this. And then we're going to go back up to the function here, go and accept the parameter number. So we do that by putting the variable inside of these parentheses up here. So now, when I go and run this, it should ask for a number. So please enter a number. Let's go ahead and put 10. And then there we go. It divides it by 5, or by 2, and we get the result 5. All right, so now here's an example of passing and accepting multiple parameters. So as you can see at the top here, we've got A, B, and C. It's accepting these parameters, so it's got the parentheses around them and the comma between them. And then we've got our code statement in the middle, obviously. And then down here, we're calling itinerary and passing 6, 12, and 9. Now notice there's no commas, no parentheses when we're passing multiple parameters here. And so we're passing numbers there. Now below that, we're passing string values. So again, no commas in between them, no parentheses. However, we do have the quotation marks since it is a string variable. All right, so I'm going to go back to this problem I was working with earlier. And now we're going to go and pass more than one parameter. So now we're going to do integer number 2 equals read host. Please enter another number. And then so here we will pass the first number and number 2 as well. We'll go up here and we will accept number 2 as the second parameter. And now we should be able to get both of these. Number 2 divided by 2. Let's do divided by 3 in this one. All right, let's go ahead and run this. It's going to ask us for the first number. So we'll give it 10, and then we will give the second number 9. So as we can see, 10 divided by 2, again, it's 5. And then we've got, please enter another number, 9. So 9 divided by 3, obviously, is going to be 3. Okay, so now returning information. So PowerShell is a little different on returning. So a lot of times you don't even need the return keyword. Some other languages you'll need the return keyword, and it might be a habit for some experienced programmers even. So in PowerShell, you just need the variable on the line by itself, and that will automatically return that variable. So for example, in this one, we have what color flag using the parameter temp, standing for temperature. And then we have a switch statement using the variable temp. So if the temperature is below 81.9, it's going to be a white, below 84, green, 87, yellow, 89, red, and then default if it's none of those, black. So the problem here with this one, the issue is that with a switch statement, it will test all the conditions. So if the temperature was 80, it would return all of these flag colors because it's going to run through, it's going to see, is the temp less than 81? Yes. Okay, print out white. Is it less than 84? Yes. 80 is less than 84, green, and then so on with yellow, red. So you have to be careful here because without the break or the keyword return here, it will keep running. So here you can see we add return here. So this will actually stop it once one of these conditions are met. So if the temperature is 80, it's going to print out white, and then it will stop running through checking for the rest of these. All right, so now testing functions. So an important thing about testing functions is knowing what you are expecting from these functions. So you can go and test parameters and make sure it runs as expected. So a lot of times when you're trying to make functions run together as a whole, you need to make sure each one works individually. So you'll need to isolate these functions and make sure they work as an individual. So in this example here on the right, we can see that we're commenting out the divides by 4 function and passing the array. So right here it's calling that and then passing that array. So assuming we're trying to check and make sure this one works as an individual, we comment this out and then we would maybe type in the build array down in the bottom panel in IAC and then would run and test to make sure this one works as just one. And then if it does work, then take out the comment here and then these two should be able to run together. So an important part of coding is troubleshooting. So some general rules here. Whenever you're writing your code and trying to execute and test it, make sure that you're reading through your code. A lot of times your errors will hold the answers that you're looking for. And, just so many times I see people misspelling like dot length and, missing the G or just misspelling any kind of word and it will mess up the whole code as to what they're trying to get from it. And again, syntax, again, another thing that's very common is messing up the syntax. I know PowerShell is a bit different, having to remember those dollar signs and then using things such as dash EQ instead of the equal equal sign if you have written in other languages, and just remembering when to use the dash EQ instead of the equals sign actually, and then, dash GT for greater than and all of that. And then so disconnecting your functions, just running through kind of like what I went over and independent testing, make sure each function works on its own. If you're running into some issues, that could be a good way to try to figure out what's going on. And then confirming that the results meet your expectations of what each function does. And so here's another thing you can do is inserting some test statements, like writing line 10 and then some variable and see, kind of what you would get from that. Just another thing is, if you're entering some numbers into your code and you're getting some weird results as to why it's not an even number or something, a common issue can be that you forgot to declare as an integer, so you can put things such as the variable and then dot get type to make sure it's the variable type that you want. And then, just writing the output value for disconnect functions. So here's an example, a bit of a practice here. So we've got our function get times result, and then accepting a and b as variables. And then in the function here, we've got c is equal to a times b, and then write the output of c. So we've got get times result here, 6 and 7. So we're going to pass in 6 will be a, 7 will be b. So then what do you think the expected result should be here? So it's going to be 6 times 7. So if you said 42, you're correct. Okay, so now I will show you guys how to connect functions and make them kind of work together. Let's go ahead and make our first function here. I'm going to name this age. Take out these parameters. And then we'll make another function called name. And take out one of these parameters, because we're going to use one from age. And then we will make a function main. Okay. So up in the age, we're going to get the user's age. So it's going to be an integer. Age equals read host. Enter your age. Okay, so now if I were to go down here and try to use age, it would not know what this is because I haven't passed the parameter yet. So what we're going to do is we're going to call the name function and pass the age parameter. So in here we're going to call it. We're going to receive this We want to call it age. We want to keep the name the same here. And so again, this really doesn't matter. I can name this param1 and then come down here and use param1 as the variable name. And this is still going to be the age variable. It's kind of strange, but it's just how this works. So you name it whatever you want it to be here. Since we sent it in here, it's taking this variable and we're receiving it here. And we can name it whatever we want. For this instance, though, I'm just going to keep it named age for simplicity. So we're going to get age. We're going to display you are blank age years old. And then we're going to ask for their name. So name equals read host. And I'm going to put what is your name. And then we're going to send name into the main function. So in here in main, we're going to go and take the name parameter. We're going to put your name is name. So again here we're sending the name parameter into this main function, accepting it here, and we're going to be able to display it here. So now when I run these, I'm going to start off, I run this. So you're probably wondering, well, okay, nothing came up here. Why I ran it, right? So it's because we're not actually telling any of these functions to start running. So we're going to first go, we're going to type age. So enter your age, 25. You're 25 years old. What is your name? Put my name. Your name is Chris. So you can see here, they all kind of ran together here. This function asks for their age, sends it in here. This function displays it and asks for their name. And then the last function just displays their name. Right, so the next part is scope, and this can be a little bit confusing, so I'll try to make it as simple as possible. So whenever you're in a function and you create a variable, that variable kind of is born and dies within that same function. So, and then anything that happens to it is only really happening in that function. You can't necessarily access that variable to change it outside of that function. So a scope is kind of like you're creating sort of a global variable here. So you can make a variable and have it at a script level scope so that can be read at all levels. So we can do this with the syntax $script, as you can see right here, and then colon, and then whatever the variable name is. So down here in our example, we've got num equals 10, and then script num1 equals 10. So this function is not going to be able to see num, but it can see num1 because it's at that, we've got that script before it, so it's at that larger scope there. Alright, so here's a few exercises that I recommend you guys should go and try to do. So the first one is just write a script with a function that prints out hello world. It's really simple. Second one, write a script that uses a function to evaluate if a given number is odd or even and returns the result. And then the third one, take any of the three exercises from the flow control lesson and turn them into functions. So again, this is really things we've already done, just putting them into functions. So go ahead and try to do those, and then we'll come back. Alright, so just kind of recap what we've gone over with functions. We went over an overview of functions, why we use the functions, some built-in functions into PowerShell, how to create user functions, how to call a function. We went over passing and receiving function parameters. We went over returning a value from a function. Then we went over scope, and then we did some exercises. Alright, so now I will go over modules. So we'll go over an overview of modules, what modules are, creating modules, and then the scope of modules. All right, so modules are like built-in functions, but they are saved as PowerShell script modules. So I can see here's an example. The resulting file is placed in a directory with the exact same name. And this folder is saved to a folder named PowerShell in your Documents folder. So I'll quickly cover creating modules. So in short, a module is a function that runs automatically every time you open PowerShell. And these can be accessed anywhere in PowerShell and used in scripts. Unlike functions, modules are always on. So a function you would have to call to get it to run, and if you're not calling it, it'll never actually do anything. However, modules, they're always on, they're always running. So in other languages, this is generally referred to as a library. So now I'll talk a little bit about the scope of modules. So module scope is global or universal, maybe a better descriptor for this because they're always on. You can use them inside and outside of functions. So modules are activated whenever PowerShell is activated. So when you open PowerShell, these modules will be running and they're accessible from any script, function, or class on the system. So again, unlike functions, they're just always going to be on, they're always running, and you can use them inside and outside of functions. So just a recap on modules here, we went over a slight overview of them, what are modules, creating modules, and then again, the module scope. All right, so now welcome to the last portion. So in this, I will be going over basic PowerShell commands and interacting with Windows. So some basic PowerShell commands. Again, this is going to be kind of what I'll be going over. We're going to go over an overview of them, why script PowerShell commands, some informational commands, some program interaction, user commands, and then the help command. All right, so why script PowerShell commands? So PowerShell is built on the Windows 32 API. In basic terms, this means PowerShell can talk to every Windows program that are native to the operating system. So we can technically build Word docs, Excel spreadsheets, Access databases, and just kind of anything like that in PowerShell. However, I would not recommend going that route unless your program absolutely required it. You're talking to those programs at a fairly basic level, so all the click and change options are now blocks of code. So again, PowerShell is fully integrated into almost all Windows function, and this creates an opportunity to include PowerShell commands into our scripts to automate and speed up many tasks. And in this, I will cover a few basic PowerShell commands. All right, so here are a few PowerShell command tips. So PowerShell commands always start with a verb and then they are followed by a dash and end with a noun. So they go from a verb, noun. That's how they are. So for example, we've got get content, get being the verb, and then content being the noun. And then some other examples there like new service, find command, show event log, read host, and then there's going to be some more as well. And then so we've got some aliases that we use to nickname for commands. So for instance, we have get service can be, the alias for that can be GSV, standing for get service, and then get content, I use this one a lot, just shortened to GC, and then stop process, which is used if you're wanting to, obviously kill a process, that can be shortened to SPPS. And so here are some informational commands, and I recommend you pause this and go through and kind of realize what these all do, but I'll cover a few of them real quickly here. So we've got get content, which we use a lot, and some of the aliases for that are going to be GC, cat, and type. And then get process can be shortened to PS or GPS. And then get child item can be shortened to GCI, LS, or DIR. And again, that's looking at all of the files in a folder. And then set location. The aliases for this can be SL, CD, or CHDIR, kind of stands for change directory. And then start sleep, which can be shortened to just sleep. This will pause execution for a short time, so you could, if you want to put some wait commands in there, before the next part of a code shows up. All right, so here are two more commands in PowerShell. So we have get process, again shortened to GPS. And what this does is it displays a list of currently running processes on a given computer system. And then we have the stop process command. And here's an example of it, using it to close Internet Explorer. So stop process, and then you'll do -name, i.e. Explorer. And again, that will stop the Internet Explorer application. All right, so here's a couple exercise I want you guys to go ahead and try to do. So go ahead and pause the video and run through these on your own. And an interesting note down here to consider is that these files are special and can be started from any directory on the computer. So those two being calculator and notepad. All right, so something I'll quickly cover here is some basic user commands. So the first one here we have, if you're creating a new local user with the name instructor, creating a password for that account, and then putting their full name, so Mr. Instructor, and then the description being not a real instructor. So the output of this would be that it would create a new local user named instructor with the attributes specified. And then the next one being, if you wanted to rename them, you could change the name to just instructor. So we've got the current name instructor and then the new name instructor supervisor. So let's say they went from a normal instructor and now they're becoming instructor supervisor. So you'd want to maybe run this script to elevate their privileges or kind of show that they've changed there. And then we have, so if you wanted to remove a user, so remove local user name instructor supervisor, and this is going to obviously remove the instructor supervisor local user. Now something to note here is that in order to perform these functions, you have to have elevated privileges like being a system administrator. You won't have these on normal computers, so to test these commands out, you would need to do them in a lab or your home computer. All right, so here's some more basic user commands. So the first one we see here is user permissions, get ACL path mytext.txt, creating a new rule, the object system security access control, and then making the username. So we've got the username and then read and allow, and then user permissions set ACL path, again mytext.txt, and the output of this would be that it would grant read or write access to the username. And so for the second one here, we've got pretty much the same thing, but user permissions set access rule protection, true and false, and then again the same path. So the output of this one would be that we pull the current permissions from the file, modify the permissions, and then update the permissions on the file. And then lastly here, again, user permissions, we're creating a new rule here with the read and allow, and then removing access rule, we're removing the new rule there. So as we can see up here, we've got new rule, new object, system security access control, file system access rule. So the output of this would be that we'd pull the user permission from the file and remove them. So essentially taking the access away from them. And then for those on the Mac operating system, here are some basic user commands for them. So for the first one being, we've got fuser is going to list the processes that have one or more files open. We have halt, that's going to start or stop the operating system. We have groups, that will print the groups, print the group names a user's in, and then ID, the output being that it will print usernames and IDs. So again, to perform these functions, you have to have those elevated privileges like being a system administrator. And again, you're not going to have those on the normal computer, so you need to test them in a lab or your home computer. Okay, and now I will go ahead and cover the help command. This is a very useful and important command to know how to use. So the help command will pull up a lot of useful information on a command, like how to use the command, what options there are, aliases and full command syntaxes, and much more. So here's an example at the bottom. We have get help net IP configuration. An alias for this could be help ipconfig, and then the output would be that it would display information on the command ipconfig. All right, so now I'll go and show you an example of what the help looks like. So we would put help ipconfig, and see, so this kind of gives us all kinds of information about it. So this is how you would use the command get net IP configuration. Here's some syntaxes for it, and just kind of more things you can do with it. So it's got some related links, so we can go look up more information about it. There we go. So I recommend going and typing get net IP configuration, and you can see all kinds of information about your home internet connection. All right, so now what I'd like you guys to do is go ahead and utilize the get child item command. And I'm going to show you guys what that'll look like here. So I'm in my C drive, users, and then my username. I'm going to go get child item, press enter, and this will show me everything that is in that directory. Got all of these folders or file names, everything that's in there. All right, just to recap here, we kind of went over some basic PowerShell commands, why script PowerShell commands, some informational commands, some program interaction, user commands, and then a little bit on the help command. All right, so real quick before I get into the last exercise, at the end of the PowerPoint, there's these two slides here, this one and then this last one. I'll just show you some more kind of helpful tools you can use and some more basic PowerShell commands and stuff. So go ahead and look at those, and then we will jump right into this exercise. All right, so this is going to be the last exercise I go over. So it's going to be create a function that evaluates a number, and if the number is even, it divides by 2. If it is odd, it multiplies it by 3, and then adds 1, 3x plus 1, and repeats this until the number hits 1, displaying the new number every loop. Alright, so I've got the CLS at the top here, and I've set up a comment block for the description of the function that we're going to be making. Alright, so first it says a function, so we already know we're going to need a function here. And then let's name it math problem. And then we know we're going to need one parameter, so we'll go ahead and set up param1. And then go ahead and set up our brackets. Okay, so we know there's got to be a loop in this because it's got to keep going. So I'm going to go ahead and use a do until loop. So kind of press Control J there, bring up my do until. I'm going to put our, so until param is equal to 1, because we're doing this until number becomes 1. So again, that's kind of why I chose the do until loop here. It just makes the most sense since it does have the word until in the problem. All right, so, and then we've got if even number divide by 2, right? So we know we're going to need an if. And then if odd, so probably going to need an if else here. Good. If param1 is even, so we're going to do mod 2 equal to 0. Then divide that parameter by 2. So param1 divide by 2. Now we're actually going to want the parameter to change to this number once it divides. So I'm going to add the equal sign here, kind of like we would do plus equals. So we're doing divide equals, so it's setting this parameter to whatever it is divided by 2. So if we get 4, then the parameter is going to become 2, because 4 divided by 2 is equal to 2. Right, now let's go ahead and set up our else. We're also going to want to display that parameter. Okay. So let's go into our else. So if odd, so if it's not even, we know it's odd, then multiply it by 3 and add 1 until number becomes 1. All right, so param1 equals param1 times 3, and then add 1. Right? So if odd, multiply by 3 and add 1. And then we'll go ahead and display the parameter here as well. All right, so now we've got our function set up. So math problem, and zoom out so I can see it all. And so now we're going to want to call the function math problem, and let's pass a number into it. So let's go 32. And go and run this and see what happens. Right, so we've got 32 becomes then 16, 8, 4, 2, 1. All right. All right, so now before I end this, I'm going to go ahead and try this with one more number. Change the 32 to a 34. I'm going to run this again. Get a little bit of a different result here so we can get into the else portion of this. All right. So the 34 goes to 17. 17 is odd, so it multiplies it by 3 and adds 1, so we get a 52. That's even, so it goes up here. We get the 26. Divides again, 13. That's odd, so it's doing this again. That goes to 40, and then that goes to 20, 10, 5. Again, the 5 goes to the else. Becomes 16, 8, 4, 2, and then finally we get to 1, so it breaks the loop, and we get out of this problem. All right, so that was the last portion I had to go over. I hope you guys enjoyed.